I'm recording.
Okay. Well, welcome to the, um, let me see. So it's October 12th, October 13th, 2020, session of Tangerine SDR and Hamsai Personal Space Weather Station talk. My name's Dave, KV0S, and this week I've been doing a couple things, kind of not directly on this project, but working on a couple of elements. I did help Scotty get some stuff figured out, as well as Dave Witten did. So now Dave won't be here tonight because he had his treatment today, I assume. I haven't heard from him yet, so I assume he's sleeping. Anyway, let's go down the list. So next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Things are going fine here in Scranton. Just continuing to move along with the project with data analysis and things like that. And Dev helped me put up a new ZS6BKW antenna on Friday. So I've got a new antenna up. W2NF back to net.
Very good. And next on the list is Bill Engelkey, AB4EJ. Go ahead, Bill.
Thanks, Dave. Good evening to the net. I've just been going through and adding some additional cleanup and error proofing into the local host front end user interface, and I'd like to show that tonight and go through it and get some feedback from the team. And also been working with Case Western Reserve a little bit on their data collection activity. And so that's about it from here. Back to net.
Fine business. And next on the list is Dan in for XWE. Go ahead, Dan.
Okay, thank you, Dave, and hello, everyone. Didn't really do a lot this week. Worked a little bit with the FPGA development board, just kind of going back through some things I'd done before. I reinstalled Quartus just for the fun of it. It's not really hard to install, but getting everything up and running after you install it takes a tiny bit of effort. Also worked a little bit with the Odroid N2, kind of updating a few things. Did the general software update, which I think updated around 180 packages, so it'd been a while since I'd done that. Anyway, that's about it from here. Back to you, Dave.
Fine business. And next on the list is David McGaw in one HAC. Go ahead.
Good evening, everyone. Been busy on a number of different things this week, but the one most immediate to this project is I was working on the magnetometer boards that David sent me and got both of them working, solder bridges, things like that. And then made an interesting observation. I noticed that when I turn one of them over, the numbers aren't quite exactly the same. You know, I did this on a number of different ones, different magnetometer. I have two magnetometer cards plus the carrier cards. And it turns out that there is potentially a bias to them, and it's from connectors. At first I thought it was the Ethernet shield. That probably has some effect, but it's fairly far away. The primary thing was the pins that I used to connect the magnetometer card to the card underneath. are magnetized. I was actually
Oh.
able to degauss them. I have a old coil used for degaussing color television sets, and it was effective. I was able to degauss them and make the measurements much more repeatable. So I think we're going to need to find some non-magnetic connectors to be used around the magnetometer. So that's my big revelation for the week. Back to Net.
Well, that's a good one to find.
That's a big one.
Yep. Well, let's see. Next on the list is Dev, KC3PVE. Go ahead, Dev.
Thank you, Dave. So we had a good start today, Monday. In the morning, I discussed my progress with the projects with Nathaniel, Bill, Lyles, and Steve. So slowly we're making some progress. And I may want to take some time in today's discussion as I'm having a small issue in installing Spectrum Lab in my Linux system. Thank you.
Okay. Let's go on through the list. Next on the list, we have Dick Patchy. Go ahead, Dick.
This is Dick, K2LCT. I did get a notice today that DX Engineering is selling the 14-bit red Pitaya for...
Dick, you're a little weak right now. Can you turn up your volume?
Is it better now? I'm talking closer to the mic.
That's a little bit better, but you're still very weak.
Okay, we'll say 73. Thanks for letting me into the net.
73. And next on the list is Gary AF8A. Go ahead, Gary.
Hey, good evening, everyone. I just want to say, Dave, thank you for making some updates to the Tangerine SDR project status page. It's nice to see who's who in the zoo and the ability to follow the links, drill down, and read the abstracts and functional specs and stuff. It's very helpful. So back to Net.
Well, it was a good suggestion. Thank you. And next on the list, we have James, KG4DSG. Go ahead, James.
Yeah, you hear me now?
Yep.
Yeah, I'm just keeping an eye on what's going on. I did see a news announcement this weekend or within the last 5 days that Microsoft has released a native version of Visual Studio Code that runs on the Raspberry Pi. People have been itching for that for a while. I haven't even loaded it yet, but it is out there on the website. Back to Net.
Very good. Well, that'll be interesting. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Nothing really much to report this week. I've been doing some documentation on the VLF module, getting everything organized and better. Some further progress on getting things more organized. Other than that, I've been just working on a lot of homework. Back to the Net.
Oh, fun. I'm glad that some of those days are past me. Next on the list is Michael, AAK.
Greetings to everyone on the conference. Back to you, Dave.
Yes. And next we have Scotty, WA2DFI. Go ahead, Scotty.
Okay, thanks, Dave. And this week I got a new toy. Oh, probably want to see that side. It comes in backwards. That's pretty cool.
Yeah.
The camera's flipping everything. Anyway, it's a RX 888 that I just got from China that I ordered about 6 weeks ago. You know, one of those things where it's a present when it comes because it's so long ago you've forgotten when it was that you ordered it. Haven't had a chance to put it on the air yet, but that will come later, I guess. But it is pretty nice and hefty and lots of heat sinks on it, so we'll see. This week, major progress on the magnetometer thanks to you and Dave, and got some pointers on how to actually test the new magnetometer. So I fired up the Odroid, downloaded Dave's code, compiled it, got that all running, loaded a couple packages that I needed, support packages I needed that Dave suggested, and found the biggest problem that I found, and I hate to even admit this on a conference where there's more people listening. On the 9615 part, when I built the schematic symbol, I reversed 2 pins. So now I have PC boards that have 2 pins backwards. So that's why the local temperature sensor worked, but nothing else did. So at any rate, I did the cuts and jumps to flop those over on 2 boards, and lo and behold, everything works. In fact, even the remote data ready line, I can signal that across the cable. So we've got pretty much everything working there. And just talked to the Tapper folks, and you've seen this, Dave, but the board pretty much decided to go ahead. We're going to do is since I kind of mitigated the pain by only having them build 5 boards. What we're going to do is we're going to take the remaining 45 boards and we're going to throw them away, and we're going to fix the artwork, and we're going to make 45 new blanks, and we're going to build the rest of them, the rest of the 50 up with the fix on it, so there won't be any wires, because the wires cost an exorbitant amount to put on. Believe it or not, 2 wires and 2 cuts in a professional shop's $30 per board. So it's just too expensive to do. But the good news is the interference fit with the Raspberry Pi RJ45 connector. We're going to fix that at the same time. Since we're redoing the board anyway, we might as well fix that. So we're going to flip it over to a tab up connector, and we're going to rotate it 90 degrees so it comes off the bottom of the board. And that should pretty much make the board production ready, I think. Everything's going to be working, and gives us a 2 to 3 week hit on the schedule. But then it's just a matter of plugging them in and testing them, and then we're ready to ship them out. So I'm figuring by, it's the 12th, pretty close to the end of the month, we'll have boards ready. So, and they'll be all tested and ready to go. So that's the good news.
So it sounds like you also ought to put a magnet on your pin runners just to make sure they're non-magnetic.
We already checked that. The RJ45s are phosphor bronze with nickel coating, so they're not magnetic.
What about the P&I pins?
The P&I pins, the header?
Yeah, there are 2 headers on either side of the P&I board that plug into your board.
Right. They're also phosphor bronze.
Okay.
So they're not steel. So yeah, so there's pretty much nothing magnetic on the board that I could come up with. I can think of. The other headers are all the same material, whether they're the dual row or the single row header. The ICs and parts like that, there's nothing I can do about those.
You can't do anything.
And so I think we're okay. I mean, I didn't do a definitive test. I mean, I took the board and I rotated it and saw that the y-axis changed, and I turned it upside down and saw that the z-axis changed. And then I got some cold spray out and sprayed it on the temperature sensor and watched it go crazy, and then slowly build back up to. And I don't know, is that reading, is that a degree C reading, or is that just a raw reading? Do you know, Dave?
That's degree C.
Yeah, that's what I thought it was, degree C.
Okay. Well, the interesting thing is I have the 2 temperature sensors read about 3 degrees difference, and they're sitting right next to each other. So I'm not sure exactly why that is, what their calibration is supposed to be, but they both, when you breathe on them, they go up. When you freeze spray them, they go down, but they don't track together. So
Might try putting a fan on them to blow some air across and see if they'll equalize.
To take the ambient air and blow them across both.
Right.
Yeah.
Yeah, because one of them is sitting on top of the Pi, so it may in fact be getting, or of the Odroid, so it may in fact be getting some heat from that.
It will definitely be getting heat.
Yeah, and I think it was the one that was warmer, so that would make sense.
Yeah.
Anyway, so almost there with the magnetometers.
Back to you,
Okay.
Dave.
Okay. Well, Tom, here you are, the last person on the list again.
Okay, well,
Thanks.
last with the
Thanks to
least.
the name T.
Well, thank you, Dave. Good evening to everybody. Nothing to report tonight. So back to Matt.
Okay. Well, that's all the people on the list, I believe. So we're open for general discussion, and we have a couple of people wanted to present things. So do we have an order? Anybody? Nathaniel, you have any suggestions?
No, I think you can just go in whatever order they want or you want.
I have a quick question for Tom, if I can sneak it in.
Go ahead.
So, Tom, John was asking about what type of clock we need for the RF modules, and I told him LVDS differential. Is that the correct answer?
Yes, I think so. It's 1.8 volt LVDS differential, and the clock module provides 100 ohm load across the pair.
Okay, because I'm going to give him the VDDIO. I'm going to give him the 1.8 volts. So he's going to drive it to whatever that data engine sets it to, because I'm going to give you the 1.8 volts also for your digital IO. So
right, yeah,
so,
it's 100 ohms differential in peaks.
Okay, great, thanks.
Well, Bill, you want to go with your? Oh, Mike.
You're muted, Bill.
Okay, all right. So share screen here. Let me see. Okay, this I think is the one. All right. You should see the main control panel of the Tangerine SDR. This is version 1 with everything working on it, with the possible exception of a few details. I don't have a nice output for the whisper spots that are detected. How important is that? I don't know, because with both that and FT8, you can go ahead and look at them on the their respective sites. Both of those are working. So, for example, let me see. I guess what I need to do here is probably, all right, I may have to change, let me change the way I'm sharing here. I'm going to try that different. I need to share this entire screen so that,
So, Bill, is this real data from your Flex radio, or is this simulated data?
it's real data. Yeah, I've got it running now where well, let's see, okay, can you see the SDR now, the Flex radio?
Yes.
Yes.
These top 2 channels, those are outputting, they're set up for on the FT8 frequency. And so we're getting 14 megahertz and 10 megahertz into the local host. This channel C is a 10 megahertz WWV, and that goes to the ring buffer. Just the way I have it set up now. You can set it up any way you want, but it's just what I have now. So I can just demonstrate running all 3 different modes at the same time. The bottom one, this is 40 meter whisper, and it may be off a hair there, because I see there's a signal, because it's kind of the right of the passband. But anyway, nevertheless, so now if see if I can find this.
So, Bill, you're running 4 separate streams then from the Flex into the
Yes, this
computer.
is a 6600. It's a 6600. You can run up to 4 streams.
Okay.
And this channel C is running at 48,000 samples per second. The simulator is in between. It takes the IQ data. All these channels run at 48,000 samples per second, but the simulator is being used to decimate the FT8 down to 4,000 samples per second and decimate the whisper down to 375 samples per second so that the algorithms that do the decoding work the way they're supposed to. Here's can you see WhisperNet there? This is the, right here you see in the lower right, you can see what GMT is, and see it's not getting a great deal of spots because I don't have the filtering set up on the data yet, but it's just getting, you know, a couple of strong signals here and there that make their way through the noise. And then here we are on FT8. We're uploading spots both FT8 and Whisper. So the FT8 stuff goes to PSK reported. The Whisper stuff goes to WhisperNet.
So you're Bill, one second again, you've got the Flex then connected directly to the single board computer, or you have a simulator in between?
I have the simulator in between because I cannot configure Flex to put out the sample rates that the decoders need for Whisper and FT8.
Okay.
It's got a very, well, when you program it not using their utilities, you're really restricted on what you can do. So anyway, the simulator is in between. It's acting as go-between. So, but obviously the simulator is, I've done everything I can to make the simulator be faithful to what we foresee that the data engine will be able to put out.
And the simulator is an Odroid also?
The simulator is an Odroid, and in the case of the local host, as of now, it's a Raspberry Pi.
Okay.
So we're running with a Pi. I thought it would be a good idea to try and use the most easily available computer for this. They're really reasonable in price. They're a lot easier to get a hold of than Odroids. So, yeah. So this is the front page. It's got a status up here, which indicates what data collection is running at the moment. So if you start from the upper left and work down, what you're looking at is the main control panel, and underneath that is, this is navigation that takes you to all the different configuration. Mostly what this thing is about, except for the front page, is configuration.
So Bill, is this is actually running, this is on the Pi, or is this being served up as a web page?
Well, the Pi is serving it up as a web page.
Okay, so you're looking at this on port 80 traffic off of the Pi on another computer? Is that?
5,000.
Port 5,000. You can make it do whatever port you want. This is just what I picked.
Yeah, okay. But the point being is this, you could look at this on any browser.
Yeah, anything that's on that has network access to the local host.
Got it, okay.
So this box here is having to do with data collection. This is the Spectrum data collection. Here you get to pick which modes you want to run. It does a little bit of, it will not let you run ring buffer and continuous upload at the same time, because that's illogical. You shouldn't be doing that. But other combinations it will do. And over here you get to pick which of these two propagation monitors you want to use, and when it tells you what's running up here. So if I do a stop monitoring, it will revise this to show that just the snapshotter is running at the moment. We can talk a little bit more about how snapshotter works in a few minutes.
What does the R on Firehose stand for again?
Okay, there are two different Firehose modes. One is remote and one is local. Firehose R is remote, where you're going to upload everything to a remote server. Firehose L, I have not implemented yet. That is where basically I configure the data engine to start spitting out data, and then it's going to route it directly to a big machine, like a big server that's on your local area network.
What's the difference between like, what's stopping you from changing the remote address to being a LAN address? Why do you need the two?
Okay, that's a good question. The thing is about that. The idea with the local host is that you should be able to configure to spit out the entire wideband spectrum of the entire data engine to a local supercomputer. That assumes that you have probably 10 gigabit Ethernet, that kind of thing. That is not something that the data engine would be able, that's not something that the local host would be able to handle. So the continuous upload to a remote server is, the local host is in the middle, and it's helping do things like throttle the data so it doesn't overwhelm users' DSL line and queue the data.
I think we lost your audio, Bill. Or I lost.
Yeah, it went almost silent. Still no audio.
Well, how about now? I wasn't talking. Let me see.
There it is. It came. It's like an intermittent.
Yeah, there's this camera that I have tries to take away control from the microphone that I'm using, and sometimes it succeeds, and then I have to manually set it back. But anyway, all right. So, but the idea is that Firehose L is the local host is not going to be in the circuit between the data engine and the supercomputer, because the local host is not able to handle that kind of data rate. So Firehose R is what you're going to use for your home user. Firehose L is going to be like, that's what Haystack would use, or that's what you would use at a university that has a big pipes and big fast servers.
So, Bill, is there a possibility, because we have USB 3 on the data engine, is there a possibility that we could have in the future a mode where Firehose L would spew the data out the USB port, because it's much faster? It's 5 gigabits per second. So it's about 5 times faster than
Yeah,
the
you could do that. I think you could do that, sure.
Yeah. So you set the stream up on with using this, and then you fire it off, and it would come out the USB port. Is that?
Yeah, I think we could probably do that. I guess that the question is going to be how much logic, how much control do you have over the server you're sending it to? Because something has to handle that data somehow. So, I mean, typically, if you have a server farm in a big organization, you're not going to be plugging anything into the USB ports of those servers, because they're in a data center, and due to security, you're not allowed in there. So I don't know, but now if you had an organization where you're going to put the data engine, get special permission to go into the computer room and then plug a data engine directly into a server, then you be off to the races.
Yeah, if you had a dedicated server.
Say again?
If you had a dedicated server.
Yes.
And I mean, even if you're not even, like, this is something even an amateur could do in their own home. You know, they want to get a beefy desktop. That'll work, right?
Yeah, so if you have an i9 high-end gamer computer that could handle this, or a fancy GPU card that you're going to experiment with GPU algorithms on.
Yeah, yeah. So that is, I mean, those kind of the reasons why I have it separated from Firehose R. Firehose R is a very specific case where you're going to collect data, say for an eclipse, at home. You'd like to upload it continuously. You have sufficient bandwidth that you can do that for a few 8 kilosample channels, and you know, no struggling with anything. You just fire it up and it works.
Well, and also the next generation of data engine is likely to have 10 gig E or some other higher speed port on it.
Yes.
That will be able to handle this. Whether the PC on the other end can handle it.
Yeah. Well, I mean, the assumption being, if you're going to be an organizational user, you're going to have a server farm with some big iron.
Yeah, that was kind of like why all the discussion about the protocol, and you ought to be able to stream different with streams to different target computers, so that if you're, I mean, maybe the computer can't handle 10 megahertz, 10 megabits of data all at once, so you'd send two streams, one to each of two different computers, and it can be over the same network if you're running 10 gig E or
Yes,
some high speed, but you can then distribute the data to the machines as much as they can eat of the data.
right. Yeah, and the protocol that I've designed for the local host and data engine to talk to each other supports that. It will support. I don't know I don't know that there's a limit on the number of streams. I mean, for phase one, the local host supports 3 streams. One stream that is for spectrum data, that is ring buffer, one stream for FT8, and one stream for Whisper. And now,
We'll just support as many streams as we can in the data engine until we run out of logic.
yeah, yeah. So, but we got to walk before we run. But we will get there. So now, if you take a look at all these different configurations, let's go down through these. This is your user profile. There will be a node number issued by a central authority. Not Carnegie, why do I always say that? Case Western Reserve has already started issuing those who are just going to continue to go with their naming convention. The call sign is in there mainly so that when spots go up to WhisperNet and PSK Reporter, the location of the receiver is known. This grid here, you specify your location purely by putting the grid in, and it calculates the latitude and longitude from that. So if I put in my actual location, see what, it's got some very coarse lat long, but I've changed it to put in my actual, and now it calculates the updated location of that. This security token comes from the central control system. That acts as a password. So the way that a system knows who you are is it gets your security token, and then it knows which device, because we're going to support multiple instruments for a given account. It knows that by the node number. So you can specify your elevation here in meters. If you are trying to put some error proofing in here, if you put some garbage in here and try and save it, it's going to give you it's going to chuck it back to you. It reverses it back to a valid value and gives you the error message up here. I might turn this to red or something, but okay, you're allowed to specify 2 antennas. I have to save these with underscores instead of spaces because just the way the configuration works in Python, it doesn't support these kinds of things with punctuation or anything like that. So if you put other garbage in there, it's going to change it back. So I think that works. If you put a space in there and save it, it puts an underscore back in. And if you put in 50-foot tower, you can't support that either, so it takes it out. So it saves it in a way that's actually uploadable, and you specify whether you have a GPSDO or not. So that is.
Sorry, go ahead.
Go ahead.
I just had a question on the node numbers. The idea then is that the security token is unique for every user, but the node number could be, a user could have several different nodes online with that same the security token, but the node numbers would be different. Is that correct?
Yes. Now the node numbers are also going to be unique. So each user is going to be issued node numbers by central host. So they're issued both the token and the node.
Is that 6 digits enough?
Say that again?
Is 6 digits enough for the token if they all have to be unique across
the node number?
Yeah, if the node number has to be unique, that's not very many nodes for the world.
Well, okay. I mean, that can grow. I mean,
Okay.
this is what we're using now. But
Yeah,
the-
alpha and
the
5
limit-
numerics is 2.6 million node numbers.
Well, that's not enough. I mean, we're gonna have more than that, aren't we?
So
Can you have, will the system be able to pull the lat long from the GPS?
As soon as we get a GPS.
that's theoretically possible. I don't know how important that is, but that certainly can be done.
How accurate would it be from the GPS compared to this, what you've got here? Because that 6-digit grid square is like, how many feet is that for per square? I mean, it's pretty small, isn't it?
Well, if you use 6 digits, it's like a neighborhood.
Okay.
The GPS should be much more
Yeah, that
Be
would
within
be
a few feet.
within centimeters. But see, the thing is, not everybody wants folk to know where their shack is all the way down to plus or minus a few feet. Because you can go and look at these and say, I think there's some nice equipment to be had at lat long so-and-so, and I can find that on a map. So we did get some feedback from some people who are security conscious. They don't even want their grid shown in QRZ.com. So, I mean, obviously we have to have that to do science.
right. And is there some sort of like, shouldn't there be a red flag being raised if the GPS is reporting one lat long and the user reports something significantly different?
Yeah, that would be interesting.
Well, we can certainly issue a warning. Absolutely. It makes every bit of sense to do that.
Because I mean, from a science perspective, I would generally trust the GPS reading over what a user enters in.
I'm making some notes here.
Well, I'm well aware that recently I've been watching Whisper, and there are Moroccan call signs being or Chinese call signs being sent from Antarctica. Now that could be true, but it's not highly likely.
So you think that they're just pirating the location?
I think they're just picking a random grid and putting it in their software.
Well, yeah, there's also a lot of stations that appear out in the, about 40 miles off the coast of North Africa, which at lat long 00.
Yes.
You see that regularly too.
Mm-hmm. Yeah, I think we really want to take advantage of the fact that these systems are supposed to have GPS and report that the GPS.
Well, it would almost seem like, though, you want to really report what the user wants you to report, but maybe you should mark it as this came from a GPS or this didn't come from a GPS.
Yeah,
so,
I think we should do that. And what we do is, I'm having a plan of getting a bunch of telemetry from the DE, and the the reported lat long would be one of those items coming, when you have a GPS system connected onto the data engine. So let's proceed forward here. Now, data collection. This is how you configure for your spectrum data collection. Now, I'm just running, hang on a second, let me go make sure stop that. All right. This is how you control your spectrum data collection. You can specify up to 15 channels, and you can go through and set what channels you want. For each channel, you specify if you're using antenna port 0 or 1. You specify the data rate you want. All these channels will run at the same data rate. That's a limitation in the current system. Because we're going to interleave the data between the channels. Obviously, they all have to run at the same rate. Otherwise, you got a terrible record-keeping mess while you're trying to unpack all of that and store it on a Raspberry Pi. It's not compatible with that. All that
But
level
if
of
you were
detail.
to run these as separate streams, then everyone would be selectable for independently. The
Yes.
rate would be selectable independently if they were separate and not interleaved.
Yeah, and I think, you know, there's a lot of things like that that are appropriate to put down on our parking lot for things to add for another phase.
Yeah.
So
Yeah, because like if you just want to watch Whisper on 4 different bands, you probably want to dedicate a small slice to those.
well, hang on,
whereas
we haven't gotten to that yet. These are just for spectrum collection. FT8
Okay.
and Whisper also run on separate streams and simultaneously with all of this.
And they aren't interleaved, right?
Right, FT8 and Whisper, they have multi-streams, but all those streams run through UDP, and each one has a stream ID, and they're interleaved buffers in time rather than interleaving samples within a given buffer.
But that means any one Ethernet packet's going to have only FT8 or Whisper data in it, not both.
Right, right. And those are separate from the spectrum stuff.
Okay. So really you got 3 streams.
Yes.
One interleaved stream, and then you got an FT8 stream, and you got a Whisper stream.
Right. So these, if you put in something like something that doesn't exist and try and save changes, it's going to tell you it can't find that ring buffer path that you tried to put in there. These, you've got to configure these, and we're going to give people, and Dan is going to do this, I think, we're going to let people build this system that fits their hardware, and it will build these all these different paths, and then they'll be ready to go, and that be put into the configuration file. So the ring buffer, you get a chance to specify how big the ring buffer will be. Once the ring buffer, the data in this area gets above 10 gigabytes, it starts throwing away the oldest files minute by minute as it's running. Then this next thing, this FFT output path, that's a snapshotter. Those are CSV files. I'll show you what those look like in Excel in a minute. This is your firehose output path. This is a large disk work area where you're going to put your firehose R files while they're waiting to be pushed up up to the central host. And this is a path for temporary files. FT8 and Whisper use temporary files. The way Whisper works is it collects 2 minutes worth of data and then decodes it. In case of FT8, it decodes 1 minute worth of data. That's actually 4 15-second segments, and it combines them together and then removes duplicates. So all of that is working.
So Bill, the large disk work area, that would be designed for people who have a big pipe, right?
Well, a big hard drive on their Pi.
Well, but you can store all the data, but then if you don't have a big pipe, what are you going to do with all that data?
Well, the firehose continuous, it will upload at whatever speed you throttle it at. If you turn throttling off, it will upload at whatever speed your DSL supports. If you're running at a university, it'll move at 10 megabits.
Okay.
So some of those things just kind of automatically adjust depending upon your settings and your situation. So uploading, here's, I've specified, I've got a virtual machine running on my system, which has this address. Now, in the case of an actual one, this will actually be a URL like https psws.caps.ua.edu, and we'll have this port, and you can limit this on bandwidth for uploading, or you can set it to unlimited, and it will throttle.
Very nice.
This throttling handles all uploads that you use, ring buffer, snapshot, or everything. I have a slot here for magnetometer setup, but I don't have any I don't have any code behind it at this point, so that's just under construction. Notification, this works with a list of well, let's go back. I skipped one. Call sign and grid monitor. If you would like to enter, if you'd like to monitor for given call signs to be heard on FT8 or Whisper, or monitor that certain grid squares are heard at your location, this is how you do it. You put those call signs in here, and you can go through and check that these call signs are valid in QST, rather QRZ and everything else. I haven't done that, but it does check that your grid square is a valid grid square. I think I've got that set up. So if you just put in garbage here, it should, okay, it should tell you grid number 1 is not a valid grid square, and it takes it back to a valid one, or just to none. So these are the call signs and grids you want to look for in notification. Now, if it detects one of those grid squares or call signs, it will send you a test email telling you that one of these stations has been heard. That's working now. That does work. And you can even configure this to address if this is your email at, if this is your phone number at tmobile.com, you'll get a text message saying that a certain call sign has been heard. So that's all working. Next one, FT8 setup. You select antenna port 0, 1, or off. If it's off, that channel is non-active. If it's on, it will assume that whatever data comes in on that channel, that FT8 channel uses that FT8 frequency, which is that is the dial frequency, assuming upper sideband in all cases. And you can turn PSK reporter spotting on or off. Same thing with Whisper setup. You can specify, I've got this running on channel 3 because just some technical matters, the way the simulator works. All this will work with the channels on the data engine once we get it. And you can turn uploading of spots to WhisperNet on and off. And I do intend on having something on the main control panel that will show a little summary of what's the last few minutes. And as you can see, it's a few minutes behind, probably because if you don't get spots for a long time because the band has gone quiet, this will just continue to show the UTC of the last group of stations you heard. And then finally, this is what I call the danger zone. These are some of your technical settings. You can, if you know what you're doing with digital RF, you can set up the subdirectory cadence to compression level. I have it set to a 1. DRF compression 0 is no compression. You can go up to 9, but it really buries the Raspberry Pi and it can't save all the data if you go above 1. But I find 1 is quite good because just the DRF compression of level 1 cuts the size of the DRF files by about 60%. So that works very well. And then milliseconds per file, that's another thing. How big are the DRF files you're going to get each? And then you've got IP settings. The DE Discovery port 1024, that's been the same since the very first HPSDR protocol. It does the same kind of discovery as all the old SDRs that were developed by Tapper going back to the first ones. And then you have config ports and data ports. This is just what the local host is going to use for config ports and data ports. The data engine will tell me what ports it wants me to use for its configuration and data, and I will use whatever the data engine tells me. So that's in line with Scotty's recommendations on how to do that. And then finally, the nuclear option. If you screw up all of this mass of different control settings and everything in your configuration,
I like it.
You can restore to manufacturer settings which throws away your call sign and grid and everything else. But at least especially if you've messed this up, I mean, if you mess up something in here, the whole system may or may not work. So anyway, but there is a nuclear option there. So that is, and you know, you can go, I don't have all of these set up with validation yet, but we will validate that these are valid numbers, that the ports exist, and we'll let you know if those ports are tied up, or if you put garbage in these values, it won't let you save it, things like that. So anyway, that is the, that's where we're at on the Tangerine local host. Now the central host, the students are getting, we had a team meeting with them, and they are getting back to work. They started quizzing me about some of the technical details regarding the uploading. So we're going to upload using rsync for the, I guess it's continuous upload uses that, and LFTP for ring buffer data, because with ring buffer data, it's digital RF, which is a file directory structure, which then has to be tarred, and so it can be managed as a file. So that's all of it. All that technical matter is up there. And let's see. Let me see. It should stop me from doing this. Okay, yeah. It detected that I tried to run ring buffer and continuous upload at the same time. So you're not allowed to do that. So you've got to turn that off. And okay, so now it's, oh, let's see. Well, good. I see it. I screwed up something in the, well, it's started running anyway. Okay, good. So now I started talking a little bit about this snapshotter. Snapshotter, if you want to work with, do a lot of experimentation with your system, what you really should do is install Samba Share, which is a file sharing thing that runs on the Raspberry Pi. So then you can go in on your Windows system, and you can okay, so this is my Raspberry Pi, and here's where my snapshotter files are. I've got it running using using Case Western Reserve's file naming convention. So we've got the date, the node number, the location, and the type of system, and the frequency. You can put other stuff in there too, but so I've had this running for several days, and see, it gives you about 43 megabytes per day. What that is, we'll open up and take a look at one of these in Excel. Oh, come on. Yeah, maybe I asked too much of Excel here.
Can't handle a measly 43 megabyte file?
Well, actually, normally it does.
And this is on your computer, your Windows computer, not on your Pi, right?
Right,
So,
it's running on the desktop. Let's see if I can try a different one. You know, what good would on live demos be if there wasn't something to go haywire? Anyway, part of the problem is that I have figured out how to create a heat map in Excel using this massive data, so you can see the signal that you're looking for wandering around through the noise as it Doppler shifts. And I did want to show that, so let me see. I have to kill Excel here.
Excel does not like to have multiple files open.
Let's kill this. And maybe see if I can show you one of these ones that I've been working with a little bit. All right. All right. So this, first of all, let's take a look at what we've actually got here. Go up to the upper left of it. This is a snapshot or file. This gives science users what they need, even if you have minimal bandwidth available. So it tells you what frequency you're on. It tells you the time and date of when it took the data. And then you've got, this is 200 values of real data centered around your observation frequency. And then 200 values of the imaginary, and then 200 values of the total magnitude. And if, all right, so here's your total magnitude starting from cell 00 and going over. And I found out what you can do here is if you select all these files, so select all of these, and then use conditional formatting and set a color scale to where the red is top and green is the lowest values. And then what you can do is you zoom away from it, the signal you're looking for starts to show up in the Excel file. So that is a spectrum, and you see one of your layering of the ionosphere going on there.
That is really cool, Bill.
Yeah, and then so you can see what else you've got here through the night, and so now then, over on the right on this, there's a couple of columns that are of particular interest. This column right here indicates the difference between the observational frequency and the frequency being received. So this is actually indicates the amount of Doppler shift observed in that time frame, which is typically about 25 seconds, I think, with the way I've got it set up now. This column is the peak magnitude of the signal that was observed during that time frame. And that last column, I don't remember what that is. But if you take this column here and then graph it, that's when you get these. These are your Doppler, and I was comparing for 2 days. This is 2 days of data layered on the top of each other. And I don't know if they're apples to apples. No, take that back. That's wrong. This top one in this case is magnitude of signal strength, and this is on 40 meters. I'm collecting data on CHU, which is 7.85 megahertz as your dial frequency. Well, 7.849 because that's the dial frequency, because I'm looking at a 1 kilohertz carrier. And so here's this is your Doppler shift in the bottom. That's what this bottom one is, and the top one is the signal strength during that time frame. So sometimes you'll see that the Doppler shift goes crazy and just jumps all over the place. Most of the time, anecdotally, I say that is associated with low signal strength, where the signal, you're really basically not hearing it, so you're just getting noise, and that you measure the Doppler shift of noise, you just get stuff jumping around. So I'm trying to, I'm working with David Kasdan. We're going to try and suss out what's going on there. But this is actual data collected. This is the same stuff you're going to be able to get exactly using the full-blown Tangerine. This is off-the-air data. So,
Nathaniel, does this look similar to the graph that Christina showed on the Thursday morning?
Yeah, it's similar.
Similar. I don't know. I mean, you have to compare, but you know, this is a time scale, right? Going across left to right.
Mm-hmm.
So it would be.
Yeah. And so here, Doppler shift wise, this is beginning of 0 UTC over here. So as the sun is going down, you see this, your negative Doppler shift, and over here is the sun coming up. You see your positive Doppler shift. That is what that is.
Yeah.
And then you see, you know, all through the day, whatever happens. And so, yeah. And then you can see that little thing there. In the past, we typically is observing that as sometimes a solar flare, but no, I don't know about that, because this is the middle of the night. Sometimes you see these little structures in the middle of the night, and my theory is it has to do with when that part of the ionosphere switches between one side of the magnetic surrounding around the Earth and the other side. It goes from one to the other, and creates a little jog and little jump in the ionosphere. Anyway, I don't know enough about it to.
Yeah, that's something we're looking at right now, where we're starting to look at. Those look like there's traveling ionospheric disturbances to me, and yeah, we see them. I've seen a lot of them at night.
All right, I'm sorry to have monopolized this with so much discussion, but this is the first time I've shown this in this level of detail to this group. So
this is great, Bill.
Yeah, this looks really good.
I have basically concluded my presentation here, and I think Dev, if he's still awake, has some things he wants to talk about. So, but anyway, guys, if you have any more ideas on what this thing needs, at least for phase one, if you have any advanced ideas, let me know. If I can do it, I'll do it. If I can't, we'll put it on the parking lot for phase two. All right, I'm going to stop the share.
Thank you, Bill.
Excellent, Bill.
Thank you.
Makes me believe we're actually going to have something that will do something other than hold the door open.
I sure hope so.
Because it looks awesome.
It's coming along.
Well, it's like something that a ham could get his hands around, because it's simple. I mean, you've simplified everything, so there's just check boxes and fill in the parameters, and then the thing works. So
well, the idea is supposed to be it should be usable by schools.
Yeah, and the checking that you've done, you can't, to some extent, you can't really break it. I mean, you can't enter illegal combinations to a point anyway, which is good.
You could probably fit, if you're really clever, you could probably fool it. But I'm trying to find all those things and error-proof them out of existence.
Mm-hmm.
So
I can't wait to get real hardware up and start doing this with our hardware.
That's me too. That's me too. But I still need to get you. Well, we're not there yet. I will get you in another couple of weeks, and I know you don't need it for another couple of months. So I will get you the ICD for the logical protocol with the LHDE.
I think you're probably going to be going back and forth a few times, so that'll be good.
Okay, back to net.
You're muted, Dave.
Well, I'm not proctoring quite as much right now. I guess Deb was the other one that had a question. Deb, I'm not sure, you were asking specific question about Spectrum Lab or something.
Yeah, I was trying to install it, and I thought like I could take a few minutes to see if there could be easy, readily available suggestions rather than me spending more time.
Well, first let's ask how many people have installed Spectrum Lab. So I have not.
So
I've installed Spectrum Lab, but only on a Windows machine.
So I'm trying to do it in Linux, and for Linux there is a software called Wine, which allows.
Ooh.
No wonder you're having problems.
There you go. Wine is good for very simple programs, but very difficult for complex.
I actually have gotten this to work. I just haven't. So I just haven't done it in like a year or so, but I have gotten it to work on Linux before.
Well, you know,
Sounds like-
your time has a value too. It really does. I mean, you might want to consider just, you could spend $500 and get a decent Windows laptop and have it up and running in like 5 minutes. And
No, I have Windows desktop, so it's not about not having a Windows machine. But I was trying to see if I can have it in Linux as well. So the issue is this. So this is it. At the last step, it continues to show me this message: installing. Please wait while setup installs Spectrum Lab on your computer. So this has happened. This continues to happen, and I have left this. It's been, I think, couple of hours. So I'm convinced that this will never be completed. So I have done it many times. I just delete it. So I tried to delete it, and that's not easy either. Okay.
If no one has a suggestion here, Dev, I can look at it with you tomorrow morning.
Okay. Okay.
The only person I think that might have some idea is Dan. Sorry, Dan.
Okay. Maybe like we're past the time, so maybe this evening we can leave.
Yeah, I'm not sure that I would have any real good ideas for installing Spectrum Lab. I have used Wine a couple of times, and as Dave says, it's great for simple things, but if you want to do something complex with lots of inputs and outputs and that need a lot of processing power, sometimes Wine fails.
Okay.
Yeah, as I said, I have made it run successfully on Linux.
And
I just don't
for,
remember the exact procedures for
okay.
doing it.
I use it on my Mac with Wine, and I even have a sound card input. What I do is I run in the command line, Wine, and then the installer, and then you go through the install process. And then once it's installed, then you type in Wine, and then the path to the executable, and it should just run like normal.
That's what I tried, and that's where like I had the error where I saw.
Dev, what kind of system are you installing it on?
Ubuntu 18.04.
No, what hardware?
It's your Dell laptop, right?
Yeah.
Okay, so it is i86 architecture, not ARM.
I think the Spectrum Lab executable is still 32-bit. At least the one I have is. I don't know if Wolfgang put out any new versions, but I think the executable is still 32-bit. If you want to bring up share your desktop, you show me the error message.
So this is Q1. I installed it from the software manager. So here it is. This is installed fine. But I want to open the Spectrum Lab, for which I have an executable here, and I can do open with Q4 Wine if I do it, and I do okay.
Jonathan, when you were talking about,
it says next.
You were talking about how you did this on the Mac, Jonathan. Did you run the installer in Wine, or did you just run Spectrum Lab itself in Wine?
So
I ran both the installer executable and the Spectrum Lab executable both in Wine from the command line.
So and after this step, like there is no progress, and I have to Stop.
Yeah, Deb, have you tried the install without creating desktop icons?
I have tried the exact same thing, and I do it from here.
Hang
No,
on.
no. I mean, when you run install, one of the option boxes was to install a desktop icon, and that's
Oh,
where it seems to be hanging up. So
oh,
if you
okay.
run the install and
Oh,
uncheck
okay,
that box,
okay, okay. Let's see.
okay, now,
So don't get a desktop icon.
okay, yeah, there you go.
That's what you said, right? No, no.
Yeah,
Yeah.
yeah, leave that unchecked.
Okay, maybe I have not tried that. Maybe if it, yeah. Thank you so much.
Hey.
Hey, there you go.
Thank you so much. Thank you so
I
much.
learned something new.
Way to go,
That
Tom.
looks good job, Tom.
Thank you so much.
Looks great.
Outstanding.
Okay. Thank you so much. Thank you.
Well, we are past our time.
But I got my problem solved.
There you go.
Fantastic.
I'd like to ask a question on the presentation, if I could.
Yeah.
This for Bill. I realize. Let me start by saying I realize this is aimed at the Personal Space Weather Station, and the questions may be futures. But correct me if I'm wrong. You're saying both fire hose modes come from the data engine and go to the local host. Is that correct?
No. Fire hose R mode is fire hose remote. That the data comes to the local host and then is pushed to a remote computer by the local host. Fire hose L assumes that there's a local high speed system right on the local area network, not across a WAN. So you've got wide bandwidth, and what it's going to do is it's going to configure the data engine to output data that is going to go directly to the receiving server without going through the local host, because it's going to be a higher data bandwidth than the local host, which is a Raspberry Pi or Odroid or something. Is more than it could handle.
Okay, that's the question I wanted answered. In the remote version where you say it is going through the local host, you're basically doing a data copy from the data engine into the Pi on the Ethernet and then back out of the Pi on the Ethernet. Has anybody done any capacity measurements on that?
Well, I have been doing it with my local system, and I found out it works pretty well, because here's why. You're running with in your local area network on this, you're running with gigabit Ethernet. And most home users are going to be uploading using DSL. So you got gigabit Ethernet, but you're uploading at something that goes maybe a megabit. And so it, you know, those uploaded packets just slip in between the other ones are so quick on a gigabit Ethernet. It's so small in comparison to the system capacity that they don't even get in the way at all. That is the data coming from the data engine. You know, and in my system, I've got many times as much data, because also running on my local area network is 4 different channels of IQ data coming out of the Flex radio. So all of those channels have to go to the simulator. Then the simulator takes and then reconfigures it and sends it again to the local host. And then the local host uploads to the server from there. And it's all has been working quite fine. I was amazed that this would all run on a Raspberry Pi. I was just pleased as punch. I did not expect it.
Well, that's good to know. I did have one other question, actually for Scotty. The USB 3 that's on the data engine, or that it's planned to be on the data engine, is that correct?
That's right. It's
Is it going to provide power?
Yes.
Okay.
Up to about a half an amp. So I think the spec is 900 mils, but I guess you can do that. But you know, you don't really want to be taxing our power supplies that much. We have lots of extra 5 volts, but you can consume that pretty rapidly on an Ethernet port.
Well, just looking forward, there are USB 3 to 5 gig Ethernet adapters on the market right now, but they're all USB powered, and they probably draw more than that.
Well, okay, I can revisit that. I'm not done yet. The chip I'm using to power that USB 3 bus has got a programmable current threshold, so we can set it to whatever our power supplies can provide.
Well, let me just throw this into the chat. It's just a sample. I just found it on a search. I have no idea what they cost. But I mean, for a true fire hose, and I realize this is futures. It's not for the weather station. But that would be a good way to get a true fire hose out of the data engine onto a local net.
It doesn't say what kind of power it requires, does it?
It does say it's USB powered, but I didn't find a power spec. I'm sure you could find it, and there are others. That's not the only one.
Yeah, I'm thinking if you could find an externally powered one, then that would be no problem.
True.
But of course, if they can do internally powered ones, that's much more desirable. So.
And like I said, it's, you know, obviously futures, but it's a bigger pipe out of the data engine than the Gig E. You probably get at least double out of that.
Well, and the theory is that it won't be very long before we'll have Gen 2 of the data engine, which will maybe use a 10 gig E, use an X2 port, or you know, a plug-in card, and then you'll be able to use fiber or copper up to 10 gig.
Yeah.
But this particular FPGA doesn't support that kind of speed, so it would have to be a much higher end boards, and which is gonna lock out a lot of people because the cost is going to be much higher.
It's going to be higher. Okay.
Yeah, so I don't know if anyone has 10 gig Ethernet network at home. I mean, that would be like a institutional thing. Tom does, of course. Is it optical fiber, Tom?
Surprisingly enough, I was looking at a motherboard spec this weekend, and they're starting to put 2.5 gig on the motherboard.
Yeah, well, and you know it's going to go that way. That was the whole reason to use gigabit, because it just scales right up.
Yeah, there are $110 10 gig multi-port RJ45 switches available now from Microtech.
How about desktops that have 10 gig ports on them?
My server's got two 10 gigs and two 1 gig ports on them, all RJ45.
And are they copper, or are they?
Yeah, they're RJ45s.
Wow. So
the price on them has really come down recently.
The pressure's on.
Yeah.
I suppose you could retrofit a card into a desktop as long as the motherboard would support that card to give yourself a 10 gigabit port on a regular desktop, wouldn't you?
Yeah, you can buy PCIe 10 gig cards. They're not that expensive. And if you get the kinds with SFP pluses, they have a lot lower latency and draw less power. The RJ45 ones are more latency and more power, but convenient.
I'm thinking of an SFP plus slot on the next data engine whenever we get there next year.
Yeah, you can also buy SFP plus plugs that contain an RJ45, and you can plug it into an SFP plus housing. So that gives you a couple of options.
Yeah, and you can get SFP cards that are optical also.
Yeah. Once you have an SFP plus, you can put in a direct attached copper cable, an RJ45 plug, multi-mode fiber. You have a whole ton of options.
So how expensive are the SFP cards?
Gosh, I've seen some of them sub $100 PCIe cards.
What I'm talking about, an SFP module that you plug into an SFP slot
Oh, you mean the like an optical or a the
Right.
direct attach copper? I've seen them down into the $15 range.
$15?
Yeah, basically it's just a twin X. It's like a 3 meter long twin X cable with a housing on each end.
Okay.
The optical versions, I think they're sub $100 for the multimode optical ones.
Yeah, because we built a system that used that needed 40 gig of data throughput,
Yeah.
and we used 4 10 gig ports, and we used either XFPs or X2 pluses. I forget. There's 3 or 4 varieties of cards,
Yeah.
but those modules, just to do to copper, were well over $500 back when we were doing it, and
Okay.
that's why I was asking. So it's
Yeah,
got a lot
it's
cheaper.
with the volume they're being produced in, they become commodity modules.
Okay.
Didn't mean to stir up a hornet's nest, but
Oh, it's good. You always got to keep what you're going to do next in the back of your mind.
Yeah.
Yeah, I'm going to start upgrading my shack tomorrow.
I just
Yeah,
upgraded mine to gigabit.
Yeah, you'll find you have to do a lot of tuning to get things to run at 10 gig. They don't run at 10 gig out of the box.
How much length of copper do you get at that speed?
Oh gosh, if you use Cat 6A cable, I think you can get well beyond 50 meters.
Okay. I know what I'm going to wire my new house with then.
Yeah. All right, it's time to go. Got to run.
Yep.
See everyone next week.
All right. Good night.
Thanks,
All
everybody.
right. 73.
Yeah.
Good presentation, Bill.
Thank you.
Yes.
Thank you.
Thanks all.
All right. We're going to go QRT here in a minute.